Hey folks, Mr. Dell here. We are looking at simplifying fraction products of fractions, addition of fractions, as well as product of decimals. So this is a question. This problem set is coming from CPM's course 2, and this is section 6.2.3, number 688. So we've got a product here. Directions say simplify each expression without a calculator. So I have a product of 73 hundredths times negative 2 sevenths, right? So I'm going to rewrite so it's a little easier to see. And when we're multiplying fractions, the whole thing is to just multiply straight across, right? That's how you find a product of a fraction. But what we can do is because these are products, right? Really, this is 73 times 2 over 100 times 7. And we know that this is a positive and that's a negative. When you multiply opposite signs, you have a negative. But notice I didn't multiply those yet. I could do the multiplication, but I wanted to show you this product just gives us that opportunity to simplify before we multiply, to allow us to have already a simplified expression. So what I look at is I think the 73, and I think, okay, is the 7 or the 73 have any factors in common? They do not. The 2 and the 100 do, so I can actually do some simplifying there, right? That 2 and 100 would divide by 2 top and bottom, right? We can actually divide out a 2, so that becomes a 1 and that becomes a 50. So that gives us an opportunity to have a smaller, to do our, when we're multiplying, is we're going to have already a simplified response. So now I'll multiply 73 times the 1 is 73, and 50 times 7 is 350. So, and we know the product is negative because they're opposite signs. So that's how I would do that question. Okay. B, now again, we're looking this time as a product of decimals, numbers that have decimal digits. So this is 4/10 times 3/10. When you're multiplying numbers with decimals, really the algorithm here is ignore the decimals and then bring it back into the answer, right? So you think of this as just what is 4 times 3, which is 12. Then look at that 12, and we've got to say, okay, now how many digits are in the behind the decimal, right? So here there's one digit, a tenth, and here's another digit, a tenth. So if I think about that, that's 2 digits behind the decimal. So when I look at my answer after I multiplied, I need 2 digits after the decimal. So the decimal place is going to go right there, right? So my answer should be 0. And always put your 0, your leading 0, 0.12, which is 12 100ths. So there's my answer, 12 100ths. And just to give some background here, when we think of 4/10, I'll show you. This is 4/10 times 3/10. If I wanted to look at it as a fraction operation, 4/10 times 3/10, and when you multiply fractions, right, it's 12 100ths, which that is what I have, 12 100ths. 12 100ths, 12 100ths. So this is the decimal version. That's the fraction version. All right. Last one here. This is addition. So when we're adding fractions, the sum of fractions, you need to have a common denominator to add fractions. So if I've got an 80 and a 10, then I know my common denominator would be 80. So I'm going to multiply top and bottom by 8 for this question. So I end up with negative 63 80ths plus 56 80ths. And then if I'm looking at this, I've got a positive and negative. So really what I'm doing is subtracting the numbers. And let's see. So because you have a negative, opposite signs, right? They cancel. So when you're adding fractions, you consider just the numerators. Once you have a denominator, you know your denominator stays the same. Once I get my common denominator. So I'm going to find the difference of those two, which is 7. And I know I have more negatives, negative 63 versus positive 56. So it's negative 7 80ths. Okay. There we go.